All right, and here we are with another video, and we are talking about domain, range, and functions with me, Mr. Hain. And our central question for today is, how do domain, range, function notation, and the concepts of continuous and discrete help me understand functions? There's a lot going on in that, so let's go back through and unpack it. And while I reread it and explain it, you should make sure that you are writing it if you are in a classroom with my notes as the essential question for those notes at the very top. Here we go. How to domain all the x values, range all the y values, and function notation, a way of expressing equations in terms of the independent variable, and the concepts of continuous and discrete, which really talk about the outputs of a function and whether or not those outputs are singular units or fractional components. Help me to understand functions. And really what we're going to be doing today is explain our thinking, your thinking, and understanding to others. So let's dive right in. Okay, so we have a relation here. 2 comma 6 is 1 point. Negative 4 comma negative 8 is another point. And negative 3 comma 6 is another one. And 0 comma negative 4 is the last one. And what you need to do is kind of put them in the table. And then we're going to put those coordinates onto our coordinate plane. Now this is a slight review. And we'll talk about domain and range as well, but why don't we just do this? Pause the video and see if you can fill these out without my help at all. There will be answers after you unpause the video, and if you are in a classroom, go ahead and pause and make sure students are working together to fill in the table, graph those coordinates, and list the domain and the range. Go ahead and pause the video. I'll be here when you get back. And we're back. So let's talk about the points. So you guys should definitely have these. If you have them in a different order, the most important part is each of those corresponding points go with each other in the same row. So 2 can go with 6, but not 2 with negative 8 or negative 4. That don't make no sense because this is 2 comma 6. I just put them in the order that they came in with the relation. So let's take a look and let's see if we can graph those points. 2 comma 6. That's positive 2 to the right and 6 up, kaboom. Negative 4 and negative 8 to the left 8 down, to the left 4, down 8, kaboom. Negative 3, positive 6, left 3, up 6, squadoosh. And we have 0 comma negative 4, so from the origin, which is the center, don't go left and right, drop down 4, and I said abracadabra. There you go. Kaboom. All right, your graph should look like this with the dots, and we talk about the domain and the range. So the domain has to be negative 4, negative 3, 2, and 0 in that order. Negative 4, negative 3, 2, comma 0, 2, and 0 in that order. And the range needs to be negative 8, negative 4, 6, and 6. Sometimes we like to have both 6s. Other times you can just write 6 once. So you could say negative 8, negative 4, 6. It's expressed both ways depending on the textbook, depending on the teacher. So there you go. We've got domain, or we've got range, and we've got the plotted coordinates on the coordinate plane. Make sure that your neighbor has these. Make sure that you have these. And if you're just following along at home, pause the video and make sure that you've got these. Let's keep on going. All right, so this is your turn. I'm not going to have any answers on the screen at all for the video. Go ahead and complete this the exact same way that we did example A. Pause the video, and I'll be here when you get back. And we're back. Okay, so let's keep on moving forward to functions and function notation. So the functions and function notation is basically expressing a y value, which we now call the f of x. So this isn't read f parentheses x parentheses. It's called the f of x. And if it was a g in front, it would be the g of x. If it was an h in front, it would be h of x. All of those things is equal to 15x. Okay, so the input is the independent variable, and that is our x. That will be on the right-hand side when we're talking about function notation. And then the y value is really just what we have here on the left. That's the simplified answer, and it tells us x comma y when we're done. Let's take a look at example C, and then we'll move on from there to kind of hammer home these points. So the f of negative 3, find the f of negative 3 if the f of x is equal to 2x plus 1. Okay, so I'm going to plug in f of negative 3 is equal to 2 times negative 3 plus 1. And again, because I'm finding the f of negative 3, I am substituting that negative 3 in for both of the x's in my function notation. So I'm going to start simplifying, and I have here 2 times negative 3, and of course that is negative 6. And negative 6 plus 1, sing the song. Same signs, add them up, different signs, subtract. I'm going to keep the sign of the larger number, so 6 minus 1 is 5. Keep the sign of the larger number, it is negative. F of negative 3 is negative 5. And that's how we read the answer. F of negative 3 is negative 5. And the cool part is, with function notation, we just gave our coordinate if we wanted to plot it. That would be negative 3 comma negative 5. And it's a way to show that the output of a function is dependent on the input for that function, and it shows us when we write it exactly what those inputs and outputs were. Awesome. So you have example D and example E. Don't get scared with the fraction, people. Just treat it like $11. And what you're going to do is you're going to simplify and both functions and find the f of 2 for D and the f of 11 for E. Go ahead and pause the video. There will not be answers, but you can absolutely check with a neighbor or the adult. I'll be here when you get back. All right, so there's going to be a lot of frantic writing, and we're going to understand what's happening here. Now, if you have my notes, there's a lot of blanks. No, you don't have to write the question. What you should do is pause for a moment and make sure somewhere on your notes, on another page, because I don't have this written down on my notes page, is the question itself. So I'm going to pause for a moment while you write down the question. If you need to pause the video, go ahead and do that. And we're back. So let's talk about, there are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of J, is a function of the number of jars of peanut butter purchased, J. So J for jars. And P of J is a number of peanuts that are in those jars of peanut butter, approximately. So how are the peanuts in jars related to each other? Well, the more jars you have, the more peanuts you have. The more jars you have, the more peanuts you have. Cool. So if you have my notes, you're going to write down the answers that we're talking about. The more jars you have, the more peanuts you have. So let's talk about G. How many peanuts make sense for this problem? Now, a lot of students are initially going to say, well, like we can talk about 3 peanuts or 8 peanuts or 1,000 peanuts or 12,000 peanuts, but really, there are only specific numbers that we can talk about. For jars, really what we're looking at is multiples of 770. So you could have 770 jars of peanut butter. Or you could have 1,540 jars of peanut butter, or 2,310 jars of peanut butter, or 3,080 jars of peanut butter. Really what I'm doing is I am multiplying 770 by the number of jars that we are purchasing. So you can't talk about 1,000 or 3,000 or 8,000 or 9,000. The only numbers that make sense for this problem are multiples of 770. Multiples of 770 is what you should write for G. So how can we write a rule that represents the total number of peanuts per jar? Okay, so now we're building that function. If there's one jar, there's 770 peanuts. If there's 2 jars, there's 1,540 peanuts. And I multiplied 770 times 2. So what you should do and what you should be thinking about is what number stays the same and what number is multiplying. Does the 770 change, or does the J change, the number of jars? Yeah, it's actually the number of jars that you purchase that's changing. So it would be 770 times J. So can we write a rule? Yeah, that rule is 770 times J. And so if I wanted to actually go more in depth, I could write that as a function in function notation, and I could say P of J is equal to 770 times J, and that would be for H. P of J is equal to 770 J. And that lets us solve letter I, or example I. How many peanuts are in 7 jars of peanut butter? So that would mean that I would have to plug that in. So the P of 7 would be equal to 770 times 7. And that is 5,390 jars of peanut butter. So it's 5,390 jars of peanut butter. So that's P of 7 is equal to 770 times 7, or P of 7 is equal to 5,390. Boom. Now we get to talk about discrete and continuous, and this is the final part of our function notation lesson for today. So discrete. So when you walk into a Stater Brothers or a Vons or a Safeway or a Giant or a, if you're in the South, a Piggly Wiggly, yeah, that's an actual grocery store, Google it. Can you actually ask for a half jar of peanut butter? Like if you walked into a store and said, hey, I'm looking for half a jar of peanut butter, they would probably say get the smaller jar of peanut butter because you can only buy single jars of peanut butter. So the output for this function is only single jars of peanut butter because the input for the function is j, and j is a jar of peanut butter. You don't have fractional jars of peanut butter. You can't buy 2.5 jars. You buy 2 jars and a small jar. So that would change our function, by the way. So it is absolutely discrete. Now, an example of a continuous function would be like how much water after you turn the faucet on for 3 minutes. So you could turn it on for 3.5 minutes, or you could turn it on for a half minute, or 10 seconds, or 12 seconds. And each of those times when you turn the water on and off, there is a measurable amount of water. And you can turn it on. The input is the amount of time, and time can vary infinitely. But whereas here in this function, when we talk about peanut butter jars, it just is just 1 jar, 2 jar, 3 jar, 4 jar, 5 jar, 6 jar, 7 jar, 8 jar. It just keeps on going up. Jar, jar, jar. Yeah, jar, jar. All right, sweet. Let's move on from peanuts and let's talk about rubber stamps. I'm going to pause so that you can write down this question, and I'll be here when you get back. I'm back. All right, so what's the independent and dependent variables? So when you buy the rubber stamps, do you walk in a store and say, hey, can I get $5 worth of stamps? Or do you say, I'd like to get 1 stamp? How much do I pay? Yeah, see, what's independent is what you ask the store for. So you're asking the store for the number of stamps, N. So the number of stamps is the independent variable. And if the stamps are the independent variable, then the cost is the dependent variable. So $4.95 is the cost. So for domain, what makes sense is what L is asking. And this kind of gets to discrete or continuous as well. Spoiler alert. Can you walk into the store and say, I'd like 5.5 stamps? Are they going to go into the back and take one of those stamps and saw it in half and then sell you 5 1/2 stamps? Yeah, no, they won't. So the domain has to be like numbers like 1, 2, 3, 4, 5, 6, 7, 8. So what do you call those numbers? There's a lot of different things that you can call those numbers. If you're in a classroom, pause the video, discuss with people around you what those numbers are. Pause the video, I'll come back. And we're back. Did you say positive? Yeah, because they have to be positive. You can't say, I'd like -3 stamps. No one's going to sell you -3 stamps. That don't make no sense. Second, you're going to be asking for the range. And so not only are they positive, but they are whole numbers. You can't say 1.5, you can't say 1 2/3, you can't say 3 3/4. So it has to be positive and whole numbers. And that is what the domain makes sense for. The domain is positive whole numbers. Okay, cool. For the range has to be multiples of $4.95 each. Now you guys are going to argue that you have to add tax, blah, blah, blah. This function is just talking about the cost before tax. So multiples of $4.95 are what you would use for range. So what do you have for L? L, describe the domain. We use 2 words. Go back if you need to find them. And for L, we talked about range, what number we are taking multiples of, and you should write that down as well. And let's keep on moving. Write a function to represent the sales, then determine the total sales for 5 stamps. So f of n is equal to what? Yeah, it's got to be 495n, 4.95n. And then we have to find the f of 5. Go ahead and pause the video, write down the equation, check it with a partner next to you, check it with the adult in the room, or check it on a calculator if you're at home, and checkity check check, you'll be ready to go with MMMMM. There you go. Did you check them? That's what I'm talking about. Let's move on. Is it continuous or is it discrete? You should know the answer because I talked about it when we were talking about L. So you should write that answer down, and if you have a sheet of notes in front of you or page of notes in front of you, write that summary. Make sure your table of contents is updated if you are in my classes. And until next time, ladies and gentlemen, keep doing the math.